Today we're going to talk about section 1.5, operations and composition of functions. We are given two functions. F is x squared plus 1, and g is 3x minus 2. And we're going to fill in the chart. When you add functions together, you literally add the things together. I put them in order from big to little, so that f of g of x is equal to x squared plus 3x. And then I have a plus 1 and a minus 2, so that's a plus 1. The domain of this is a parabola, so your domain is going to be all reals. Right? When you subtract them, it helps to have parentheses, so you'd have x squared plus 1 minus 3x minus 2. I use parentheses because it reminds me to distribute the negative, and our result is x squared minus 3x. This becomes a plus 2, so this is plus 3. I have another parabola. The domain is all reals. And the domain of both of these is all reals also. Okay? F of g, you're going to multiply them. So you got a FOIL, you got x squared plus 1, 3x minus 2. If I FOIL, I get 3x cubed minus 2x squared plus 3x minus 2. That, again, is all reals. This one causes a little bit of problems because we're going to divide them. So you have x squared plus 1 divided by 3x minus 2. The bottom cannot equal 0. So 3x minus 2 equal to 0, and you get 3x equals 2. So x cannot equal 2/3. So that's my domain, goes from negative infinity to 2/3, and then 2/3 to infinity. Because the resulting function, this one, that 2/3 is excluded from the domain. All right, we got some examples. We're adding and subtracting them. It says restrict the domain when needed. Well, you only have to do that if you're finding something in terms of x. So if we were doing g of x minus f of x, we'd have to restrict the domain. Okay? In this one, all you do is plug in 2. You get 2 squared is 4 plus 1 equals 5 minus, oh, I did it backwards, sorry. Time out, back up, easy mistake. They want g of 2, so I put 2 in here. You get 2 over 4 minus 1 is negative 1, minus 2 squared is 4 plus 1 is 5. Negative 2 minus 5 is negative 7. There's no restriction involved there. Okay, if I did it in terms of x, you'd have x over 2x minus 5 minus x squared plus 1. You have to, x cannot equal 2/5, right? No, 5/2, because you get x in the mirror, 0. So that'd be the restriction on the domain. All right, same thing here. If you plug in the 3, you can add the two functions together first, x squared plus 1 plus x over 2x minus 5, and you plug in negative 3, and you get 9 plus 1, and you get negative plus negative 3 over negative 11. You end up with 113 over 11. There's no restriction. You're just doing math. If you're going to add them together, that's what you have in terms of x. You have to exclude 5/2 again. Okay? This time I'm going to divide. F of x is on top. This is x over 2x minus 5, which is the same as x squared plus 1 times its reciprocal here is 2x minus 5 over x. In this case, my domain is going to be restricted to the restrictions on g and my restrictions on f and the restrictions on that. Okay? So x can't equal 0 because 0 is in the denominator. X can also not equal 5/2 because it's not included in the domain of g in the first place. A little confusing. Pay attention to the domains you start with. Okay? We're going to do a couple more. this one, remember that this is the same of g of 1 minus g of root 3. If you plug in 1, you get 1 minus 2 minus 1 minus, the square root of 3 squared is 3. 2 times 3 is 6. So now what do I have? Negative 1, that's plus 5 equals 4. Be careful on this one. When you plug that into here, you get 1 minus 2 times x plus h squared. You have to FOIL. That's not x squared plus h squared. I know you weren't thinking that. You know better. Okay, I've got x squared plus 2xh plus h squared. Now 1 minus 2x squared plus 4xh. Nope, sorry. You got to make this negative and that one's negative, because you're multiplying by negative 2. Negative and negative 2h squared. Okay? So don't forget to FOIL. The difference quotients is a big concept that we'll use again in calculus. This shouldn't say formula, it should say difference quotient, so fix that in your notes. It's used in calculus all the time. What you do is you find f of x plus h, just like we did here. You plug x plus h into the function, and then you subtract the function itself. So if I plug in x plus h, you get minus 2 times x plus h plus 4. Okay, that's the first function. Then I'm going to subtract the function as it's written, negative 2x plus 4, and divide the whole thing by h. Now distribute and simplify. So you get negative 2x minus 2h plus 4 plus 2x minus 4 over h. The thing that's interesting when you do the difference quotient, if you've multiplied correctly, all the terms that do not have an h should go away. Okay, minus 2x doesn't have an h in it, and there's a positive 2x, so those go away. That has an h, so it stays. No h in the 4, and that's a positive 4 and a negative 4. They cross out. So what I'm left with is negative 2h over h. You factor out the h's, and you're left with negative 2 as an answer. Sometimes you're going to have an x in your answer, sometimes you aren't. Okay, let's do the same thing again. X plus h in here, you get 2 times x plus h squared minus 3 times x plus h plus 1. Then I'm going to subtract the function as it's written on the paper. Minus 3x plus 1. The whole thing's divided by h. If I clean this up, you get 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. Distribute your negative here. Minus 2x squared plus 3x minus 1. All divided by h. Now go through and look for the ones that don't have an h in them. There's no h, no h, no h. And ask yourself, do they cross out? A positive 2x and a negative 2x. Negative 3x, positive 3x. Positive 1, negative 1. And I'm left with 4xh plus 2h squared minus 3h over h. And I can factor an h out of all of those. So one goes here, one of those, and that one. And I'm left with 4x plus 2h minus 3. And that's the difference quotient. Important concept when you go on to calculus. Last topic today, composition of functions. We have f of g of x, which means you take the function g and put it into f. You could also do g of f of x. They're not the same. You're going to put f into g. The thing that's important here on domain, it's the domain of g such that the g of x is in the domain of f. Okay, so these get a little complicated. I've got a couple extra examples to show you. All right, so f of g of x. So I put g inside of that, and you get 3 over x minus 3. And x cannot equal 0. Okay, I put f into g. Remember, the domain of this is all reals. But when I stick it in here, you have x cannot equal 1/3, because this would be untrue. When you put the function inside of itself, it's 3 times 3x minus 3, don't forget that extra minus 3, which is what? 9x minus 9 minus 3, which is 9x minus 12. And you plug in the 4 and you get 36 minus 12 equals 24. That's just a basic competition. We're more apt to ask you questions like these, and they want to restrict the domain. I have 2 more examples of those, and then we'll come back to that problem. Okay, so this is my example. Let's see, that was 5. So this is 4b. I have f of x is equal to x squared minus 9, and g of x is equal to the square root of 9 minus x squared. If I do f of g of x, you get square root of 9 minus x squared minus 9, which is 9 minus x squared minus 9, which is negative x squared. So you think the domain should be all reals, but it's not. Okay? You have to go back to this problem, because g is the one that's getting put in the other one. This domain, okay, the domain of g is negative 3 to 3. Therefore, the domain of the whole composition is this. Okay? Because this restricted what got put into the function in the first place, so you can't have any more than that when you're done. Here's another example, 4c. I have f of x equals the square root of x, and g of x equals x squared plus 4. If I do f of g of x, so I'm going to put this in here. I'm going to take the square root of x squared plus 4. That is not the same. Okay? No. All right? What's the domain of that? That's all reals. I can put any value in there, and you're going to end up with a positive number, and it'll work. And because this is all reals, and that's all reals, that's your answer. If I do this in reverse, g of f of x, so I put the square root of x in here, you get x plus 4, and you think it's all reals. But it's not, because what's the domain of that? Okay? Domain of f is 0 to infinity. So therefore, that's the domain here. Okay? Those are complicated. Make sure you do enough practice of those problems. Our last thing today is this application problem, which is a little confusing. Here's the shoreline. Okay, a ship is traveling 20 miles per hour parallel to the shore. So he's up here, going this way. There's my ship. He's 5 miles from shore. That's 5. And there's a lighthouse right here that he passed at noon. Okay, that's my lighthouse. Express the distance s between the lighthouse and the ship. Okay, so that's this. That's s. As a function of d, this is d. Okay, so we know that s squared is equal to 5 squared plus d squared, or s is equal to the square root of 25 plus d squared. Then it asks us to express d as a function of time, the time elapsed since noon. So we know he's going this way at 20 miles an hour, so distance is equal to 20 times t, assuming t is in hours. Now they want us to do s of d, so they're going to want us to put this inside of that function. So I'm going to replace d with 20t and end up with s is equal to the square root of 25 plus 20t squared. Okay, so it's giving us the distance with respect to time. What would the question be? After 2 hours, how far is the boat? Is the ship from the lighthouse? Okay, that's all we got for today. Thanks for listening.